Okay, let's see. A 4.2 gram lead bullet going 387 meters per second strikes a block of wood. Let's pretend that 75%, right, of its kinetic energy is absorbed as heat. What amount of lead would melt? Okay. Okay, so here's what we're going to do is we're going to take the kinetic energy of that, right? And we're going to multiply that by 0.75, right? And that's going to be the heat that is generated, right? As it's absorbed as heat, right? Okay, and then what amount of the lead would melt if the original? Okay, so then that amount of heat we're gonna figure out. We're gonna take that lead and we're gonna go from 23 degrees Celsius to 327.5, and that's gonna be Q is MC delta T, right? Okay, and then what's left over, right? So presumably there's enough to heat it to its melting point, right? And then whatever's left over, so we're going to subtract this stuff, right? We're going to subtract this Q, right? Okay. And then whatever's left over, we're going to set equal to M times L, right? So let's do that. Let's do that. So we got 1/2 times 0.0042 times 387 squared, and then that's times 0.75. So 0.5 times 0.0042 times 387 squared times 0.75. Okay, so we've got that the heat absorbed is 235.886 joules of heat, okay? Now, to heat it up is going to take how many joules? 0.0042. I'm just using MCAT, right? So some of that heat we got to use to heat it up to its melting point. And lead is 130, right? And then it's going to be 327.5 minus 23. I don't have room. Okay. Okay, so 0.0042 times 130 times parentheses 327.5 minus 23. Okay, so it's going to use 166.257 joules, okay, to heat it. So now our maths looks like this. We've got 235.886 minus 166.257. How much do we have left? Let's do this. Minus. We've got 69.629 joules to melt, right? So let's set that up. 69.629 equals some mass that's going to be melted. It won't maybe melt all the lead, but maybe it will. I don't know, right? Okay, and then this is our latent heat of fusion, 2.5 E4. Okay, so let's divide that by 2.5 E4. And I get that the mass that's melted is 0.002785 kilograms, which is 2.79 kilograms, which is what we got for an answer there. Okay, so the strategy again is you take the kinetic energy, 75% evolves as heat, right? Where the other 25% goes, we don't know. It's an arbitrary question, right? And so that value is this, right? And then we need 166 joules just to heat it to its melting point. And then the remaining 69 joules melts 2.79 kilograms, or 2.79, grams, okay? All right. Hope that was exciting.